Over the last year or so of dealing with COVID, antibodies have won a place in the public's collective vocabulary, along with PCR and mRNA. Antibodies were first talked about as a way of detecting if someone had previously been infected and fought off the virus, even in cases where they had few or no symptoms. After that, Regeneron and Eli Lilly developed antibody treatments for use in severe cases. Then, when vaccines started to be introduced, antibodies became an important measure of how well the shots could invoke immune responses. Antibodies are an important measure of immune response, to be sure, but they aren't the whole story. Here we'll talk about why antibodies aren't everything when we talk about immunity. The adaptive immune system, that is, the part that lets us fight back against pathogens we've never seen before in a specific way, generally speaking has two big classes of cells: B cells and T cells. B cells have antigen receptors on their surfaces that recognize dangers that are outside of cells, for example, a virus before it has infected a cell. Two things happen when a B cell recognizes its target. The first is something I talked about in another video: an expansion and differentiation of cells that release their receptors into the blood to go find, bind, and neutralize more antigen. We call these receptors antibodies when they're released into the blood, but some of the receptors stay on the cell surface. The second thing B cells can do is activate the part of the immune system that deals with dangers that come from within a cell, like an infected or cancerous cell. These are T cells. T cells rely on the fact that all cells with a nucleus display bits of the proteins they make on their cell surfaces. This is like a clothing store putting some pieces in the window to grab attention. The immune system patrols, making sure that only the right clothes are being displayed. When B cells have encountered a pathogen and eaten it up, they display its proteins, the clothes, on their cell surface to activate T cells. The activated helper T cells sound the alarm, which attracts killer T cells to come along and, kill the infected cells. And how can these killer T cells tell the difference between a healthy cell and an infected cell? It looks at the displayed proteins. If the cell is displaying anything weird, say a viral protein that doesn't belong, it knows to kill the cell right then and there. If everything is fine, it moves on. As always with immunology, there are many more details and caveats that I've left off for simplicity's sake. But for all the attention that antibodies get, and deservedly so, more direct handling of infected cells happens by other mechanisms. It takes multiple approaches and cell types, many more than I've talked about here, to form the robust and effective adaptive immune system that we all enjoy.